Hey hackathoners. So in cases where NFTs and their metadata are user-generated or complex, verification is typically performed centrally by the DApp who owns the contract and issues the minting of the NFTs. These DApps are generally dependent on contracts they have published and control due to the importance of having reliable underlying assets. Storage is done decentrally, and the goal for this project is to make verification this way as well. Project DeepWater is an NFT management system specializing in verifying metadata. It utilizes Chainlink functions to review the metadata prior to mint and Chainlink automations to cycle through the minting requests. The contract follows ERC 1155 standards and expects metadata and verification data to be stored on IPFS. A decentralized solution for verifying NFT metadata prior to mint enables dApps to feature content generated from outside their tooling solutions, and in some cases, it may offset minting costs. A clearly defined pre-mint verification solution with proper ownership controls could also allow multiple dApps to operate reliably on a core set of contracts. Let's go through an example. Here's a mock-up of some metadata I want to submit to be published on our ERC 1155 contract. Here is the verification file that metadata will be compared against. The IPFS CID for the verification data is hard-coded into our source code of our functions request. In our functions request, we make two HTTP requests to pull both the verification data and the data submitted to be minted. There are then two parts for verifying the metadata. In part one, we check the structure is correct. In part two, which hasn't been implemented yet, we check that the metadata meets any uniqueness requirements, tolerance checks, and things like that before being published. Here's the actual contract that manages the minting and verification requests to Chainlink functions. That source code is actually stored on the contract and sent to a functions wrapper that manages the function requests. The DeepWater contract manages a minting queue, and you join that queue by calling this function and submitting your IPFS CID. Chainlink Automations monitors this queue, and when a new submission is provided, it executes a Chainlink functions request to verify the submission. Once a IPFS CID has been processed by Chainlink Automations and we've received a Chainlink functions response, we read that response, and if approved, we issue the mint. Here's an example of a DeepWater join queue call with the CID of the metadata I showed before. And when we check the ticket number that was provided from join queue, after a few minutes, we can see that the IPFS CID was accepted and approved to be minted. Thank you for watching and listening. Please review the DeepWater README for a quick start guide to get up and going quick. Thanks.